Breaking vectors into components using PhET. There's two ways of doing this too. Using a PhET simulation that I'll go over in this video, or if you want to use trig, you can watch the next video instead. We're going to be breaking up vectors into horizontal and vertical components using the same PhET program that we did before. So you can go ahead and get to the link in your notes. Also, if you want to bookmark this link, it might not be a bad idea. We're again going to be exploring vectors in 2D. And I'm going to turn on the values and the angles so that I can see things a little bit more easily. Okay, so let's go ahead and look at the first example here. We've got a 20 Newton vector up and to the right at an angle of 30 degrees from the x-axis. And I'm trying to find the horizontal and vertical components. So if I go to the PhET program, what I'm going to do is add in a vector. And there's good news and bad news. Finding components using this method are not going to be perfect. You may need to play around a little bit and you'll get close, but it's not going to be exact. The good news though is that PhET will actually do all the calculations for you and basically tell you what the x and the y, or the horizontal and the vertical components are. So we were looking for a force that's 20 newtons at an angle of 30 degrees. Okay, so I can move this around and you can see there's no way that I'm going to get it exactly at 20. I mean, it's like 20.2, 19.9. And I wanted it about 30 degrees as well. So this may take a little bit of playing around, and yeah, that seems pretty good. 30.5 degrees, 19.7 is the magnitude, that's the length. And that seems pretty reasonable. So this AX here actually is our X or horizontal component is 17, and this AY is the vertical component or 10. What may also help just making that a little bit clearer is to show the components. So if we show the components using this button here, you can actually see how that one vector can be also represented as a sum of two vectors, one vector to the right and one vector up. I add those in the tip to tail method and I end up with my original vector that's up and to the right. So that's what we're doing when we break up vectors into components. So in the x direction, again, the horizontal direction, we got 17, and in the vertical direction, we got 10. So I'll go back and enter those into the box here. So the horizontal was 17 newtons, and my vertical component was 10 newtons. So since PhET kind of did it for us, there's not really much to show our work in this example. The math and scale conversions are actually going to come up in the next one. So let's go ahead and take a look at that. Okay, so now we have a 120 Newton force that's up and to the left at an angle of 65 degrees from the negative x-axis. So I'm going to try and do the same thing as I did before, but I can't make this go to 120, and that angle is measured from the negative x-axis, and this keeps measuring it from the positive x-axis. So I am going to have to do actually a little bit of math. So let's start by scaling down the force. Instead of having each box represent 1 Newton, let's instead have each box represent 10 Newtons. So I'm going to put that in my scale, that one box equals 10 Newtons. So that means what I'm going to do is basically make my vector smaller by a factor of 10. And 10 is a nice round number because that makes my math easy. It allows for a reasonable number of boxes. In this case, it'll actually end up being about 12. Somewhere in the range of 10 to 12 boxes is probably something that's reasonable to fit on our grid. All right, so we have our original force was 120 newtons. I'm going to divide that by 10 newtons per box, and that's going to give me 12 boxes. Now for the direction. So it was 65 degrees from the negative x-axis. So let's take a look at this. The negative x-axis is actually 180 degrees, but I don't want to go quite that far. I want to go actually about 65 degrees up from that. So 65 degrees less. What I'm going to do, come over here and I'm going to subtract 180 degrees minus 65 degrees gives me 115 degrees. So I actually now want something that's 12 boxes at 115 degrees, and that's something that I can do. So let's go ahead and try to get close to something around 12 boxes and 115 degrees. Okay, so that's not too bad. So here then you can see my components in the x direction or the horizontal direction. That's -5, negative telling me it's to the left. And in the vertical direction I have +11. That's the number of boxes, not the actual force. For the horizontal, I had -5 boxes. And for the vertical, I had 11 boxes. And since my scale was 1 box equals 10 newtons, what I'm going to do is multiply by 10 newtons per box. That gives me -50 newtons for the horizontal times 10 newtons per box is going to give me 110 newtons for the vertical. And that's my final answer. -50 newtons and 110 newtons. All right, one more example. So here I've got a 60 Newton force at an angle of 75 degrees from the y-axis. We could again use a scale of 1 box equals 10 newtons, but I'd worry that a vector that's only 6 boxes long might be pretty small, and since it's kind of hard to get things exact, we may be off by a box or two. That could make a big difference out of 6 boxes. So what I'm actually going to do is use a scale of 1 box equals 4 newtons. And the reason why I'm using that is 4 goes nicely into 60. When in doubt, feel free to use tens, hundreds, 1000s as your scale. Or even generally, if you get stuck, you can ask me and I'll probably give you a reasonable scale to use. So for a scale of 1 box equals 4 newtons, I'm starting with a 60 Newton force. I'm going to divide to make it smaller, to shrink it down. I'm going to divide by 4 newtons per box. And that gives me 15 boxes. And then the other thing too was the angle. So this is 75 degrees from the positive y-axis. The positive y-axis is 90. And in this case, it's less than that by 75. We actually don't always subtract. If it was 75 degrees the other way from the y-axis, we would actually add. So make sure you're thinking about how far it is, whether it's further, whether it's not as far as our primary axes. And that's like 90, 180, 270, or -90. And of course, 0. So we said it was not quite as far as the y-axis. The y-axis was 90 degrees. And it's not quite that far by 75 degrees. And that gives me 15 degrees. So I have 15 boxes at 15 degrees. And let's see if I can find something that will match that. So again, doesn't matter where you put this, so you may need to move it around so it can fit. And what I want, 15 at 15. So that's probably about as good as I'm going to get it. 14.6 at 15.9 degrees. And then here you can see our components are 14 in the x direction, that's positive. 4 in the y direction, that's also positive. Okay, so my horizontal component was 14. My vertical was 4. Ooh, but that's actually not newtons. Make sure that's boxes. And remember that each box represents 4 newtons. So what I'm going to need to do is multiply by 4 newtons per box. 14 times 4 is 56 newtons. And 4 times 4 newtons per box gives me 16 newtons. So my horizontal component is 56 newtons. Vertical component, 16